Settle in for this one. It's going to be a long one. All right, let's talk about the early hydrosphere, the water stuff. All right. So where did all this surface water come from? Well, it actually came from a couple of spots. One you might not have expected. So outgassing from erupting volcanoes was responsible for the early atmosphere and for some of Earth's surface water. That water vapor that was emitted cooled and condensed, rained back down, and that's what began to form the surface water of Earth and the oceans. Currently, more than 90% of surface water is in the oceans, and this water has been around since the beginning of Earth, whether it started off inside the Earth or elsewhere. Because another source of surface water was intense bombardment from icy comets, believe it or not. So some of the water on Earth was thought to be brought here from when early Earth was still being hit with a bunch of space stuff, hit with a comet. Now, a comet is an asteroid, which is space material 10 meters in diameter or bigger, but it's covered with ice. An asteroid covered with ice is what a comet is. So it's believed that the majority of Earth's water probably came from these two things. Maybe more so one or the other, perhaps the volcanic outgassing, but it is thought that some of the water was brought from these comets. Interesting, huh? So this is actually an image of a comet in space. You know, we don't see this specifically with our eye. It's kind of rare that we see a comet, but you will usually see two tails. This is a trail of dust. This is a trail of gas that includes water vapor that's being kind of burnt off the comet as it's flying through space. So that's how we know these things. Well, one way we know these things have water or have ice. Okay. So anyway, these two actions accounted for rapid accumulation of surface water. And again, in volcanic eruptions, some of the outgassing, the gas that escapes, a good contingency of it is water. That's in vapor form, gaseous form, but if it cools and condenses, it can come back down to Earth. So we have these two things. Volcanoes still erupt, and they still release water vapor, but kind of like all things, the processes are the same, but the rate has changed. The rate of which this material is being outgassed from a volcano has decreased considerably because the amount of heat needed to generate magma has diminished. Less heat, less vaporizing of material, less outgassing. So in the Hadean eon, there was about 4 to 8 times more heat, all right, kind of being generated within the Earth than there is now. So a lot more volcanic activity. Even in the Archean, about 2 to 6 times more energy, depending on when you're looking at the Archean, heat that was going on within the Earth. So still more volcanic activity than now. But with less heat, outgassing decreased. So that's why we tend to not continually create more and more and more and more and more water on Earth, at least due to outgassing. Okay? So I kind of lied because that's it. So yeah, so water comes from two places, at least that it's thought of, from volcanic outgassing or ice-covered comets. Pretty interesting. Now, I heard actually a fun fact from my friend Neil deGrasse Tyson, famous astrophysicist. And when we look at the Earth and the continents and all their mountains and then the basins of the ocean, we think, oh my gosh, like, you know, these big differences. Well, not really. Neil deGrasse Tyson once said, if you were a giant and you could fit the Earth in the palm of your hand, even with all the mountains and the ocean basins, we think of these as huge structures, but in the context of the Earth, they're really nothing. So if you were a giant and you held the Earth in your hand and you got rid of all the water so you could, understand the mountains are there and the ocean basins are there, they're actually so tiny compared to the whole Earth that if you were a giant and you were to rub your hand on the Earth, it would feel as smooth as a cue ball that you play pool with. It's how minuscule. When you're talking about mountains a mile or two high, but when we're talking about the Earth being thousands of miles wide, a mile or two doesn't really do much. So in any case, there's not a lot of water on Earth is what I'm trying to say. But what we do have is precious, and it comes from outgassing and icy comets. At least that's what we think. So anyway, let's pause here. So when we come back, we'll talk about the origins of life. Let's get into the biosphere now. All right. So let's go ahead and pause here. I'll see you back here in just a second.